Welcome to today's lesson on the real number system. Now, as we go through the notes, you're going to have a lot of information thrown at you. But what I want you to take from this lesson is here's the big picture. So the big picture is we're dealing with the real number system. We're only going to deal with the real number system in algebra. You might hear about things called imaginary numbers or complex numbers. That's not for us this year. So we are dealing with just the real number system, and the real number system is split into two different categories, rational numbers and irrational numbers. And we can tell what a number is by looking at it and seeing what characteristics there are. So let's dive in. So up at top it said that one of the main number systems is the real number system. Let's highlight that. And real numbers can be broken into two categories, rational and irrational. And if we look at this chart off to the side, we can see that's happening. The real numbers are the big number set, and then it's split into rational and irrational numbers. We can also see that the rational numbers have integers, whole numbers, and counting numbers down below. Those are the subcategories. So maybe we need to talk about what these types of numbers actually look like so we can identify them. So moving on, here are our number sets down below. So we have natural counting numbers. Basically, these are the numbers that you started learning way back in elementary school. Before we even knew there was something called zero, we talked about just the counting numbers, numbers that we can count by. Then we moved up into the whole numbers, which really didn't change much. We just talked about the fact that we could throw that number zero in there. Then we built off of that. Then it became the integers. So the positive and negative whole numbers. You did a lot of work with these in middle school, adding, subtracting, dividing, multiplying them. Now, all three of those number categories are rational numbers. So what is a rational number? Well, a rational number is actually any number that can be written as a fraction. Now, some of you might be like, what? How is an integer written as a fraction? Well, if we take a look up top, we can see that I could write the number 6 as a fraction because 6 over 1 is still the number 6. So any number that can be written as a fraction is rational. And things that we know, repeating decimals, this is kind of the one that a lot of people get confused on, that repeating decimals are actually rational because they can be written as a fraction. So this one here I'm just going to star, the 0.3 repeating. So anytime you see it repeating, a decimal repeating, it's rational. Which now brings us into something called irrational numbers. Irrational numbers are the exact opposite of rational. If you think that your mom is being irrational, or your dad is being irrational, or your brother or sister are being irrational, you basically say that they're kind of acting crazy. They're not making sense. And that is the same thing in math. Irrational numbers cannot be written as a fraction. They're decimals and basically any number that doesn't end, so doesn't end, and doesn't repeat. So it doesn't end and doesn't repeat. Notice that rational and irrational numbers can both be positive or negative. But if we look at some of the examples of all of the irrational numbers, you can see it's like the square root of a non-perfect square, where up above we saw the square root of 100. Well, the square root of 100 is really 10, and 10 is actually a counting number, a whole number, an integer, so of course it's rational. But if you try to take the square root of 31 on your calculator, which you could try right now, you're going to find that it turns into a big mess. You might remember doing stuff like this in the Pythagorean theorem unit in 8th grade. So it's not going to work, it's not going to be rational, it can't be written as a fraction. And then, of course, last but certainly not least, we're going to talk about the real numbers. Well, not too much because real numbers are actually just all the numbers that we're going to talk about this year. Let's try that again. The real numbers. So the set of all rational and irrational numbers. Again, I'll repeat, all of the numbers that we talk about this year will be real numbers. So moving on, we can use our calculator to help us with finding whether a number is rational or irrational. But something that we definitely need to keep in mind is that it is not ever going to have a dot 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 on the end. So it's never going to tell you if the number goes on and on forever or if it repeats. We have to use our kind of mathematical reasoning skills to tell us whether or not that's happening. So let's take out our calculator and we need to see an example of a rational number and an irrational number. So let's first take 94 over 111. Okay, so here I am now in my scratch pad, which is this key to the left, and I am going to type in 94 divided by 111. And then I'm going to hit enter. And yikes, it gives me a fraction as an output. And I want to see this as a decimal. So there's a few ways that we can do this, but the most, I would say, the easiest way is your calculator will give you a decimal if you put in a decimal. So I'm going to do 94 divided by 111, and I'm just going to follow that on 111 with a decimal point and push enter. And aha, now I can see that I have a decimal output. Now, one thing we want to keep in mind is that it ends in a 7, but if you notice it's 0.846, 846, 846, 846, it should still be 846. Your calculator is just rounding. This is a repeating decimal. So let's head back to our notes and let's write this out. We know that 94 111ths is really 0.846 repeating. Another way that you could write this is 0.846, 846, dot, dot, dot. Notice how I didn't use the 7, okay? So we have to think, what does this calculator mean to, or what does this answer on the calculator mean to us? Let's do the same thing for the square root of 7. So to find the square root sign, we can see it's right above the x squared key on the left-hand side. So I need to hit Control x squared, which is going to give me that square root symbol. Then I'm simply going to put a 7 underneath and hit enter. So now you can see we have a decimal that doesn't have any type of pattern. It appears to not be ending because it's quite long, and in fact, because it is the square root of a non-perfect square, it's going to keep on going forever and ever and won't repeat, therefore making it irrational. So let's write this out. And that looks like a terrible dot, dot, dot on the end of my number, so let's fix that up and put dot, dot, dot. Notice how both numbers have a dot, dot, dot at the end, where my rational number has a repeating pattern of the 846, and my irrational has no pattern whatsoever, but they both still do not end, don't terminate. So just make sure that you want to pay attention to rounding and repeating decimals when you're using your calculator. Okay, so moving on to the next page, there's a question here, and it says in all of these questions below, we need to first determine if the numbers that they give us are rational or irrational. Then we need to evaluate and then determine if the final answer is rational or irrational. So what I'm going to do is maybe just above each one of my numbers, I'm going to state whether or not it's rational or irrational. So in part A, 5 is rational, it's a whole number. We're adding a rational and an irrational number. Notice how the square root of 8 is not a perfect square. So let's talk again about what is a perfect square. Well, a perfect square is any number times itself. So is going to give us a perfect square, I should say. So 2 times 2 is 4. So 4 is a perfect square. So 2 times 2 is 4. 4 is a perfect square. 9 times 9 is 81. So 81 is a perfect square. 7, I don't know why my screen keeps doing that. 7 times 7 is 49. So 49 is a perfect square. Well, no number times itself is 8, so the square root of 8 is not a perfect square, the square root of a perfect square. Let's just go through and label maybe some of the other ones. We're just going to do step 1 for all of these. So B, any number that can be written as a fraction is rational. So of course B is rational times rational. C, well, the square root of 15. Is 15 a perfect square? No, it's not. So this is irrational times irrational. Moving down to part D. Well, a lot of you might know that pi is an irrational number. It's a number that goes on forever and doesn't repeat. So irrational plus irrational. And E, moving up to part E, the square root of 89. Well, 9 times 9 is 81. That is a perfect square. That number, square root of 81, is really 9. So this is rational times a rational number. F, there's pi again, irrational plus rational. G would be irrational plus irrational. Moving on, H, well, it's a fraction and a whole number. Both are rational. So rational plus rational. Moving up top to I, that's an irrational plus another irrational. Neither one of those are perfect squares. J, looks like I'm taking a rational number and multiplying it by an irrational number. Hopefully you guys are getting the hang of it. K would be rational. It's a decimal. And a fraction. It's a decimal that ends, I should say. And a fraction, of course, is rational. The square root of 25 is rational because it's actually 5, but the square root of pi is still going to be irrational. So what we've done is we've gone through and we have written what types of numbers we're actually performing operations with. So right now, you might want to pause the video, and now I just want you, using your calculator, so pretty quick, maybe 1 or 2, maybe 2 or 3 minutes, I want you to just type in all of these expressions in your calculator and get a numerical answer out. And pay close attention to using the dot 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 at the end. Okay, so here you can see all of the answers. A couple things that you should be paying close attention to are the dot 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 at the end and whether or not your number is correct or incorrect. If you're having trouble with your calculator, that would be something that you probably want to take a minute right now and circle it if you can't figure out why you got it wrong and ask me in class. So now what we need to do is determine if everything that I have written in blue is rational or irrational. Remember, rational is a number that can be written as a fraction. Irrational is something that can't be written as a fraction, so a non-repeating, non-terminating decimal. So A, it looks like a rational plus irrational is irrational in this problem, and B, it's rational. It's a fraction. And irrational times an irrational is rational. An irrational plus an irrational is irrational. A rational times a rational is rational. An irrational plus a rational still looks like it's irrational. An irrational plus an irrational looks like it's still irrational. A rational plus a rational, still rational. It's a fraction. This should have been, looks like I made a typo earlier, an irrational times an irrational is irrational. Wait a minute, that looks like it's conflicting. So part A and part C look like they're conflicting with one another. We might need that in a little bit. Let's keep going. J, a rational times an irrational is irrational. A rational plus a rational, it's a repeating decimal, so that's still rational. Be careful of that one. And L, a rational times an irrational, is still irrational. So what it looks like we need to do down below is put a check mark. Is it always, sometimes, or never true? So it says the sum of a rational and a rational. So we're adding a rational and a rational. So part H and K. Looks like it's always going to be true. I've tried to give you a bunch of examples that should work here. So we're going to use up above to kind of guide us. So always true. B says the sum of a rational and an irrational. So we're adding, remember sum means add, a rational and irrational. So we're adding a rational and an irrational, so part F. Let's see if that's anywhere else in A. Check it out. Looks like it's always going to be irrational. How about C? The sum of an irrational number and an irrational number. So we're adding two irrational numbers together, like in D and G. Looks like that's always true. Now let's move into the product. So we're multiplying a rational and a rational. A rational and a rational in part B, a rational and a rational in part E. Looks like they're both rational. That's always true. All right, keep on going. So the product of a rational and an irrational. So the product of a rational and irrational. So L and J, looks like it's both irrational. That's an always statement. And last but not least, an irrational times an irrational. That's part C and part I. Notice how one time it ended up being rational when we multiplied the same irrational number times itself, but in I it ended up being irrational. So this is going to be our sometimes true statement. So that, my friends, concludes our lesson on the real number system. I hope that you enjoyed it. Make sure, if you have any questions, that you bring them with you to class.